All right, so equivalent rational expressions and also non-permissible values. Right, so determine if two rational expressions are equivalent and determine any non-permissible values. So let's not worry about writing fractions. So let's go down here to definition. Rational expression, a fraction that has a polynomial for both the numerator and the denominator. For example, 2x over 3x plus 4. Okay. So I just want to get that definition out of the way. And it's in a fraction, so let's go look at some equivalent fractions, right? So equivalent rational expressions, equivalent fractions be the basis of them, right? So let's write some fractions equivalent to, let's say equivalent. All right, can't spell. Equivalent fractions. So what's 1/2? What's an equivalent fraction for 1/2? 2 over 4. What's another equivalent fraction for 1/2? 3 over 6. What else? 4 over 8. Okay, so as long as you do the same thing to the top as you do to the bottom, right? So in this case, times 2 times 2. In this case, times 3 times 3. In the last case, times 4 times 4. You just do the same thing to the top and the bottom. You could also write something like this. I don't just have to multiply by a number, I can also multiply by an expression, right? In this case, like x plus 2. And that would give us x plus 2 over 2x plus 4. That's an equivalent rational expression, right? Not equivalent fraction anymore in the sense of fractions. We tend not to have variables in there, but it's an equivalent rational expression. And if I did that, it would also have a non-permissible value, right? So x plus 2, I can multiply the top and the bottom by x plus 2, right? That's what's going on. Times x plus 2 times x plus 2. The only thing is that that x plus 2 can't be a 0, right? Because if x plus 2 is equal to 0, then the denominator would become 0, and the expression is undefined, right? Whereas the original is 1/2, and I want this to be equivalent. So what value of x would make this 0? -2. So the way you find it is just set x plus 2 equal to 0 and work it out. So what would x have to be? Well, if x plus 2 is equal to 0, then x would have to be -2. Okay. And that is the non-permissible value or restriction, right? So we call them restrictions. So written this way, non-permissible value, non-permissible value. So the non-permissible value is that x equals -2. If x is -2, that's not permitted. And the restriction, so we can also state this as a restriction. So the restriction is stated as what x cannot be. So the restriction, we say x cannot be -2, right? It's not allowed to be. If it were, then that denominator would work out to 0, and we'd be trying to divide by 0, and that's not defined, right? You can't divide by 0. So that's restriction. Let's say I had 8 over 28. What is an equivalent fraction to this? Bless you. 4 over, oh sorry, 2 over 7, sure. So how do you get that? What are you doing to the numerator and denominator? Divide by 4. So as long as you're doing the same thing to the top as you are to the bottom, then you will get an equivalent expression, right? An equivalent fraction or equivalent rational expression. And even this 1/2 is considered to be a rational expression, right? It's a polynomial, 1 over a polynomial, 2. Polynomials don't have to have variables, they can just be numbers. So just a regular fraction, 1/2, is considered a rational expression. Okay. Something like this would be more what we think of as a rational expression because it's got variables in there and also has non-permissible values. All right, so important points, just do the same thing to the top as you do to the bottom and you will get an equivalent rational expression. All right, either multiply or divide numerator and denominator by the same terms. Okay, I got some idea. Let's go back to here. So equivalent round, Josephine is an accomplished long-distance runner on her school track team. She has completed 3 kilometers of a 10-kilometer race in 15 minutes. She wants to finish the race with an average speed of 0.25 kilometers per minute. Okay, or a quarter of a kilometer per minute, or 250 meters per minute. In how many minutes must Josephine run the remaining 7 kilometers? Determine the time in minutes that Josephine must run the remaining 7 kilometers. Andrew's solution. Let x represent the time needed for Josephine to finish the race. He says, by analyzing the unit kilometers per minute, I know the formula for speed is distance over time, right? Units are kilometers per minute. Even if we're talking driving your car, it's kilometers per hour. You know that kilometers is a distance measure and hours is a time. Total distance is 10 kilometers, and the total time is the original 15 minutes plus the remaining amount of time. This gave me a rational expression in x for Josephine's average speed. So she's going to run a total distance of 10 kilometers. She's already spent 15 minutes. She's going to spend this amount more, and I want that to average out to 7. Determine the time. We want that to average out to 0.25 kilometers per minute. Let's just pop ahead. 0.25 kilometers per minute is 1/4 of a kilometer per minute, expressed as a fraction. I wrote an equivalent fraction for 1/4 with 10 in the numerator, so I could compare the denominators, right? So we want 1/4, but we multiply by 10 over 10, so she's got 10 over 40, and the reason is to have 10 both up here and down there, right? And now I can solve this and say, well, if these guys are both 10, then these two things must be equal, and x works out to 25. Now, we're not really worried too much about this, but again, here's non-permissible value defined. The value of a variable that makes the denominator of a rational expression equal to 0. For example, 10 over 15 plus x is undefined when x is negative 15, because this creates a 0 denominator. Therefore, x equals negative 15 is a non-permissible value. And the restriction, what we would generally say, is that x cannot equal negative 15. So we tend to state restrictions as what x can't be. X can't be this. X can't be that. Otherwise, it's all good. Sometimes we use the terms interchangeably, non-permissible value and there we go. Non-permissible value and restriction. Determine the equivalent rational expressions. Write a rational number that is equivalent to 8 over 12. Okay, what can we get equivalent to 8 over 12? 2 over 3, 4 over 6, 16 over 24, 80 over 120. Not equivalent, right? You can give them as many as you like. Okay. Now, notice, I ask you guys, hey, give me an equivalent rational. First thing you jump to is the simplest form. And the simplest form is when you can no longer, there's no common factors, right? So 8 over 12, if I made that 4 over 6, that's not simplest form because they're both divisible by 2. So it becomes 2 over 3. And sometimes we go the other way. We're just making things more complex, right, in the sense of making this multiplying by 2 instead of dividing by 2. So don't always think that I have to get that in simplest form, right? You're just looking to say, are these equivalent, right? Or give me an equivalent expression. So this one, write a rational expression that's equivalent to 4x squared plus 8x plus, or sorry, 4x squared plus 8x over 4x. Here, let's do this over here. 4x squared plus 8x over 4x. 4x squared. Now, if you want simplest form, then what you have to do is you have to factor the numerator, and if possible, factor the denominator, right? So step one in getting a simplest form is to factor numerator and denominator. So the common factor is 4x. Right, now it's only got 2 terms. There's a plus sign in there, so we know it doesn't factor the difference of squares. Right, we need 2 terms with a minus sign, both of which were squared. This isn't, right? 4 goes into 4 and 4 goes into 8, so we got 4. They share an x. This leaves me with x plus 2. Now, anytime you factor something, just quickly multiply it out and check that you've got the right thing. So I got 4x squared plus 8x. Okay, that's what I want. On the bottom, we've got 4x. Now really, before we go any further, we need to state restrictions. What's the restriction? So what can't x be? 0, right? X cannot equal 0. Now, usually I do that after I factor the numerator and denominator, but the denominator is already factored, so we don't have to worry about that. We can just state the restriction. So hey, what value of x is going to make 4 times x 0? If x is 0. Okay, so x cannot be 0. Now, we can cancel off the common factors. When you cross off, you replace it with a 1. Okay, this doesn't disappear. Okay, and we're left with x plus 2. Okay, that's x plus 2 over 1, but it's x plus 2. Now, I think it just said determine an equivalent rational expression, right? What did it say? Determine an equivalent rational expression. That's right, a rational expression is equivalent to. So that means 4x squared plus 8x over 4x. I could just say, hey, let's divide the 4 out of the top and then cross off the 4's. So I get x squared plus 2x over x, and again, we got to start here at the beginning. You always state the restriction, so x cannot be 0. There's another equivalent rational expression. This one is in simplest form, right? Keep in mind, it's not always simplest form we're asking for. And let's start with 4x squared plus 8x over 4x, and let's multiply by x minus 2 over x minus 2. Okay, nothing wrong with doing that. It's going to give me another equivalent rational expression. As long as I multiply both numerator and denominator by the same thing, then I will get an equivalent rational expression. Okay, before we start, if I'm going to do this, what are my restrictions? X cannot be 0 or 2, positive 2, right? Good. So what I'm saying is, what value of x makes x minus 2 equal to 0? X is 2. That becomes the restriction. So it can't be 0 and it can't be 2. So we need to list all the restrictions. Okay, whenever we start off, list all the restrictions, right? What can it be? As long as that's true, it's not 0 or 2, then these will be equivalent rational expressions. Okay, so we can FOIL this out. We're going to get 4x cubed minus 8x squared plus 8x squared minus 16x over 4x squared minus 8x. Okay, so FOIL, first, outer, inner, last. Collect like terms, 4x cubed These guys are gone. Minus 16x over 4x squared minus 8x. And as long as these conditions hold, then this is equivalent to this. So they are equivalent rational expressions. All we're doing is multiplying by the same, multiply the numerator and denominator by the same thing, whether it's a number, like 2, or an expression, like x minus 2, or divide numerator and denominator by the same thing. In this case, factoring and canceling common factors. So this is the simplest form of this original expression, but these forms are also equivalent forms. Okay, that's what we're looking at. Which of these is equivalent? That could be the question, right? Which of these is equivalent? All right, let's see the solution that they have. Nathan's solution. Okay, A we did. Rational expressions. Oh, multiply top and bottom by x, giving you 4x cubed plus 8x squared over 4x squared. Again, the restriction. Sandra's solution, she's going to do division, so 8 over 12 simplified. And here did what we did, factoring it down and coming up with the simplest, right? Since x is the denominator, I need to state a restriction to avoid dividing by 0. Factored it and crossed off the common factors. Verify the rational expression above is equivalent, right? Yeah, what else? Determine non-permissible values and then state all restrictions. Okay, so what can't x be? Four. What can't x be? That one. What can't x be? Now, it's hard to tell, right? So here's what we have to do. Whenever you've got something like this, you're going to have to factor. So we go x minus 5, right? Check that out. We got x squared minus 5x. So if you have a denominator that's not factored form, factor it. And now you can say, okay, x can't be 0 or 5. Okay. So from an unfactored form, that's hard to tell, right? So we factor it, then we state the restrictions. Okay. So if you're simplifying a rational expression, your first step is going to be to factor everything and then state the restrictions. And then if you are making equivalent rational expressions, just to go ahead and make an equivalent rational expression. Negative 15. Okay, so determine the non-permissible values, right? Start with this, factor it, figure out what the x values are, 0 and 5. What you really want to do is set it equal to 0 and then solve, right? Say what values make it 0. Once you've got those are called the non-permissible values. These are called the restrictions. Mostly I'm going to ask you what are the restrictions, right? So again, figure out the non-permissible values, and that's where it's x equals 0 and x equals 5. Then turn that into restrictions. X is not equal to 0. X is not equal to 5. What else? Your turn. Write a rational expression that has non-permissible values of x equals negative 2 and 0. Okay, so then the restrictions would be x cannot equal negative 2 and x cannot equal 0. So how can I get an expression which has those? So think about it, this gave us 0 and 5, right? But where do we get that from? We got that from the factored form. So I want a factored form. Well, okay, this is what's going to give me a 0, right? I want a restriction of 0. I'm going to put an x down here. What's going to give me a restriction of negative 2? What do I put in here? X plus 2. All right, here's how to work it backwards, right? You said the non-permissible value is x equals negative 2. I'm going to add 2 to both sides and get x plus 2 equals 0. And that's what I'm going to write here. Okay. So you can take a restriction, x can't be negative 2, turn it into a non-permissible value, x is negative 2, and then solve that, just make sure that this side becomes 0, and say, how do I get this right-hand side to be 0? I'm going to add 2 to both sides. So, what's the restriction here? Can't be 0. Here, can't be negative 2. Okay, so you can work backwards from non-permissible values to a factored form. And it says, write a rational expression. Okay, throw 1 up top. Doesn't matter what goes up top, right? You can put a x squared plus 3 up top. Okay, anything can go up top. Just at the bottom, it's important that you have the 0 and an expression whose value x equals 2, set that equals to 0, and then you get x is negative 2. Okay, determining if rational expressions are equivalent. For each of the following, determine if the rational expressions are equivalent. Okay, so let's just look at these. What do we got? 9 over 3x minus 1 and negative 18 over 2 minus 6x. 9 over 3x minus 1. 9. And the other one was negative 18. Question is, are these equal? So how would you handle that? What would you want to do? Find a simplest form of both. That would work. But what else could you do? How do I get from 9 to negative 18? Multiply it by negative 2. So then the question is, if I multiply this by negative 2, will it be equal to that? Right? So the question I'm asking is negative 2 times 3x minus 1 equal to 2 minus 6x? Right? Or let's just evaluate this. So what do we get? We get negative 6x plus 2. What's another way to write negative 6x plus 2? 2 minus 6x. Okay, so we can say, yeah, these guys are equivalent, right? If I multiply this by negative 2 and I multiply this by negative 2, I get this. And now this has changed its form around a bit, right? Because we don't see negative 6x plus 2, and we have to realize it doesn't matter what order you add or subtract as long as you keep the signs on there. So I've got a minus 6x plus 2, 2 minus 6x, these are the same. Okay, what was the next one? 2 minus 2x over 4x. 2 minus 2x over 4x. And x minus 1 over 2x. Okay, so what do you want to check? Or how do you want to check? What are we going to look at?
4x by 2.
Divide 4x by 2. Okay, so if I divide this by 2, I get that. So the question is, if I divide this by 2, will I get that? So we want to work out 2 minus 2x divided by 2. Okay, common factor. You get 2 times 1 minus x over 2. Cross off the common factors. We get 1 minus x. Is that the same as x minus 1? No. Right. Signs are reversed. Right, we got the same term. I got an x minus 1, but here it's the x that's negative. I'm subtracting the x, so they're not the same. This you can rewrite, right? 2 minus 6x. This you could rewrite as negative x plus 1, but that's not the same as x minus 1. So they are not equivalent. Okay, they're not equivalent. All right, give me a moment to look at that, think about it for a sec, and say, you're right, they're not equivalent. You go when you must.
Okay.
We will try not to miss you that. Sure it'll be good. Determine the non-permissible values. Okay, so again, how do you get it? Set it equal to 0. 3x minus 1 equals 0. Solve that. 3x equals 1. X equals 1/3. Okay, and then the restriction would be x is not equal to 1/3. Here, you should factor it. You don't have to, but it's always a good idea to factor it. And then 1 minus 3x equals 0. 1 equals 3x. 1/3 equals x. Okay, since they are the same rational expression, then they should have the same non-permissible value. Okay, and I think this is just somebody's solution to the thing, right? And again, we should start off with non-permissible values or restrictions. I think I was bad on that. Max decided that the rational expressions are equivalent by evaluating each expression for x equals 1. So another way to try and figure out if things are equivalent is to just put in a value and say, do I get the same number? Okay, so Max tried that and he put in 1. So we get 1 minus 1 is 0 divided by 4. What's 0 divided by 4? 0, right? 0 divided by anything is 0. 5 minus 5 is 0. 3 times 1 is 3. We get 0 over 3. Still get 0. So Max is saying, hey, if I put a 1 in there and they're both 0, then they must be equivalent. Do you believe that? Now, I'd believe it if Max didn't have zeros. What if we put a 2 in here? That gives us 4 minus 1 is 3 over 8. And put a 2 in here, and we get 5 minus 10 is negative 5 over 6. And I don't think, 3 over 8 is the same as. So if he just happened to pick a value where they both evaluate to 0, it's not true. They're not the same, right? So, no. They can't really be the same. This is x squared minus 1, right? What do we know? That looks like this. X plus 1, x minus 1. That's not equivalent. This is equivalent to 5 times 1 minus x. So these guys aren't the same. Even how would I make this into this, right? I mean, here, I've got to multiply by like 3/4, right? To do that. Multiplying this by 3/4 is not going to give me this. So watch out, right? Sometimes you might put a number in to say they're equivalent. Okay, we can go back a page and do that. Or here, we could go put a number in and say, are these equivalent? So put in, let's pick a good number. Let's put 0 in. Gives me 9 over negative 1, which is negative 9. No, it's not going to work here because that's got an x up there. I don't think those are. Yeah, so what was the original question with that? Oh, these guys here. You put a 0 in here, you get negative 9. You put a 0 in here, you get negative 9. If it works once, try it again. Pick another number, right? Put a 1 in here. So 3 minus 1 is 2. That's 9 over 2. Put a 1 in here, we get negative 18 over negative 4. That's 9 over 2. So those are equivalent. So sometimes you can check equivalency by substituting a value in, but sometimes you can't. Okay, so you just have to watch out. Key ideas. A rational number is the ratio of two integers. A rational expression is the ratio of two polynomials. Negative 2/5 is a rational number. It's also really a rational expression, right? Even though, but we tend to look at rational expressions more in terms of having a variable. 5x plus 2 over x minus 3. Remember, you got a state restriction. X cannot equal 3 is a rational expression. Strategies that are used to write equivalent forms of rational expression are similar to those used to write equivalent forms of a rational number. Multiply numerator and denominator by the same factor. Divide numerator and denominator by a common factor. Need to know, a rational number is undefined when the denominator is 0. As a result, all rational expressions are undefined for values of a variable that make the denominator equal to 0. These values of the variable are called non-permissible values. Okay, and then we write them as not equals, and then we call them restrictions. So we're pretty much always going to say, do this and state the restrictions. The non-permissible values of variables are the values that make the denominator 0. We just do that. If the denominator contains a binomial, the non-permissible values can be determined from the factored form. All non-permissible values must be stated as a restriction. Substitution can be used to determine if two rational expressions are not equivalent, but it can't be used to determine that two of them are equivalent. So if you could put a 1 in and say, hey, I'm going to get different numbers, and you say, well, these guys aren't equivalent, but even if it does work out, you can't state that they are equivalent. You'd have to do something else, right? Like prove. Okay, let's go here. And let's see what we can do. Let's just do a couple more. So 3 minus 5x over 4 plus x. What's the restriction here? X cannot equal -4. I'm going to multiply by 2x over 2x. Okay, it's going to give me 6x minus 10x squared over 8x plus 2x squared. So this and this are equivalent rational expressions, right? Now, when you're trying to determine on a test or on the quiz or on the diploma and that, really it's just saying, all right, like, how do I go from 3 minus 5x to 6x minus 10x squared? Oh, yeah, I'm going to multiply by 2x. If I do that to the denominator, will I get this new denominator? If the answer is yes, then they are equivalent. Now what if we make it more complicated? So 3 minus 5x over 4 plus x, but I'm going to multiply by x plus 2 over x plus 2. Okay, what are my restrictions? Here, -4, here, -2. Okay, now, you see binomials, good idea to put parentheses around them, right? You're going to have to FOIL this out. So we're going to get 3x plus 6 minus 5x squared minus 10x over, and on the bottom, 4x plus 8 plus x squared plus 2x. And then when we write it from the x squared term on down. So this becomes -5x squared minus 7x plus 6. And this becomes x squared plus 6x plus 8. And that's equivalent to 3 minus 5x over 4 plus x. Okay. These guys are equivalent, right? As long as what? As long as x is not equal to -4 or -2. Now, if you wanted to show these guys were equivalent, you basically have to kind of back it up, right? You have to take this and factor them. So it becomes 3 minus 5x times x plus 2 and 4 plus x times x plus 2. Once they're factored, you can state the restrictions, then you can cross this off and say, yeah, oh, okay, they are equivalent. Right? So if you get trinomials, you need to determine something equivalent or simplest form, right? Simplest form. Factor the numerator, factor the denominator, state the restrictions from the denominator, cancel any common factor, top and bottom, and then you're done. Okay, so lots to do in the book.